Let's determine if the following molecules are polar or nonpolar. Capital H, capital C, capital N or hydrogen cyanide, capital S, capital B, lowercase r subscript 2 or sulfur dibromide, capital C, capital S subscript 2 or carbon disulfide, capital P, capital B, lowercase r subscript 3 or phosphorus tribromide, capital B, lowercase r subscript 3 or boron tribromide, capital C, capital H, capital C, lowercase l subscript 3 or trichloromethane, capital C, capital B, lowercase r subscript 4 or carbon tetrabromide, capital S, capital F subscript 4 or sulfur tetrafluoride, capital H, capital C, lowercase l or hydrogen chloride, capital O subscript 2 or oxygen. To help you figure this out, I've drawn the Lewis dot structures of these molecules. Pause the video to determine whether each molecule is polar or nonpolar. The Lewis dot structure for hydrogen cyanide shows that the outer atoms are different elements, hydrogen and nitrogen. So this is a low symmetry molecule or polar. The Lewis dot structure for sulfur dibromide shows two lone pairs on the central atom of sulfur, which means it is low symmetry or polar. The Lewis dot structure for carbon disulfide meets the criteria for a high symmetry or nonpolar molecule. The outer atoms are the same element, sulfur, and there aren't any lone pairs on the central atom of carbon. This is a nonpolar molecule. The Lewis dot structure of phosphorus tribromide shows a lone pair on the central atom of phosphorus. So this is a low symmetry or polar molecule. Boron tribromide has the same outer atoms of bromine and no lone pairs on the central atom of boron. This is a highly symmetric molecule and thus is nonpolar. The Lewis dot structure of trichloromethane shows there are two different elements for the outer atom, so this is a low symmetry or polar molecule. Carbon tetrabromide has the same outer atoms and no lone pairs on the central atom, so this is a nonpolar or high symmetry molecule. Sulfur tetrafluoride has a lone pair on the central atom, so this is a low symmetry or polar molecule. Hydrogen chloride is a diatomic molecule with a polar bond. Thus, it is a polar molecule. Oxygen is a diatomic molecule with a nonpolar bond, since the difference in electronegativity for the same element is 0. Since it has a nonpolar bond, it is a nonpolar molecule.